Yo, Penguin. I'll do a little bit of silence today. Or now, I mean. Because it's late here and yeah, soon I think I can talk more. was this coming from? Nab. Okay. Just type npm install Tailwind. I think it's like hyphen CSS. Have you followed the instructions? Yes, this is Sig Yoshitoshi. Where are these coming from? This is strange. Like this. Yeah. So the memory leak is reported here from evaluate pipeline render command part 664, which is here. Okay, this is a ref that we get from, is like a reference counter reference. We get it from this thing here. Apparently this whole thing, well, it creates a couple of pointers. It creates like 3 pointers, I believe, and all of them gets leaked, which doesn't make sense to me, because we append this into this argv, and then this argv is then used down here. Also, I'm logging everything out in argv, and I don't see the things that get leaked. And I don't know how that happens. Because it's like we're adding everything we're adding in here, and then we go through everything in there and print it out. But it still says we've got leaks. So we're printing out everything. Here are all the memory addresses. This gets released and initialized. This one, here's the spec added. This gets released or deinitialized there. These do not match. These, oh, maybe it's because of the OX. Maybe. No. This one. No. I was hopeful. I was hopeful. I'm sorry, Nab. I'm speaking low because my son is trying to sleep in the other room, so that's why. But thank you for being considerate. I will not be here for too long. I just wanted to fix this and maybe do advent of code. Maybe. We'll see. No problem. But why? I don't understand. Here, this doesn't make sense to me. Like the leaks are reported. Evaluator 664 is here. This gets appended here. Yeah. Oh, here's like a return, I mean, retry. Oh. Wait. Well, okay. Hang on, maybe we should do this down here. Or are we using it? Yeah, we are using that. We're using it here. But then there is a defer here which is supposed to be... Oh, you know what? Our spec argv is never populated. So it never goes in here. I see. Okay. Well, there is actually a kind of easy fix for this because we are using reference counters. So we can actually do this. We can do our for argv items and then arg.release. So that releases this argument or this reference. But then down here, if we ever get to this point over here, we actually want to make like a copy here. Actually, we will do like argv spec argv equals arg try argv to own slice, and then we'll loop through arg spec argv and then we'll just make it into its own ref. Oh. There we go. We just make a new ref. No? Wait. Do we have issues? No. $280. Oh, excuse me. Sorry. Okay, so this must be like command, like value result, and then the argv's. Now we should only have like one argv basically, and that should be released at this point. Because we are returning here, but I just want to see what the address is before that. So here we can see value resolved 280, the initialized this one and this one. Okay, so that was not, or hang on. Aha, wait. That's that one. Oh, script execution error, empty command. Okay, now we get more leaks. Okay, script empty command. Oh, we're doing a clone here, which makes a new ref. Yeah, but that's fine because this is from the look, from the scope. Oh, hang on. This is why. This should be spec on. There we go. Okay. Yeah, now it runs there. Okay, so this leak is up here. Aha, that's the spec. Okay, now the specs is leaking. Okay. What about you? You're that one. And you are this one. Okay, good. We have more. Please be found. Yes, it's that one. Yeah, okay, they are released one time, but okay, good. That's all the leaks. Okay, good. Now, why are they leaking is the question. We are making a ref, and the argvs are actually like they are released. So we're like transferring that. These are released at the end, and then if we need them outside the scope, we're making a ref. So we're doing that here, and then we're putting that in there. So why And then ultimately these are released also, spec argv. So we should really get 2 releases on these ones. Like they're added here. Where's the second release? Here's 1 release. There should be another release. That's the deinitialize. I don't understand why we don't get 2 now. Because we have 1 here for the spec argv. And you have 1 here for the argv in here. Hang on. Yeah, maybe this hasn't been added yet to this list. What happens? It gets added. We append into specs. Yeah, it is added here. And then that gets executed. We see hello. Something gets deinitialized here. This gets deinitialized. That is this one up here. But then we get a bunch of leaks. Okay, I wish I could get like a call stack in the message here. I guess we could do like a panic or something. I don't know. Hey, Nav, did you try my tip for you there with Tailwind? It's kind of unfortunate with that kind of ecosystem right now. Like some of the projects, like some of the tools you need is like it's easier to use a scaffolding sort of jumpstart project for some of them. Some of them you're like, yeah, you have to use some sort of like initialize script to get a project. Just realized that zig devs can be called that thing. I don't like it. It sounds too edgy to me. It's like being 12 years old or something. There's nothing wrong with that, but not always the best humor. Releasing one spec. Yeah. And these are the things. So, okay. And then here, releasing arg B. Zero args. One arg, zero spec, zero args, one spec. Oh, I see. So when we do that 2 owned slice, this gets transferred. So before we do that, actually here, well, then we can just use the same refs, I guess, instead. Yeah, we could just, we don't need to ref here. We just do, yeah, we just do that. There we go. Hey, cool. All right. Okay, let's try the mutability now. Okay. Script execution error not allocated. Called release on non-allocated RC. Could have something to do with this. Like if I remove this, we don't get the error. So let's check the reassignment. Right, so we're doing a move, and that will not make a new reference. It will reuse the same, but the thing is, like, if we deinitialize the original value, the ref. Wait. Yeah, so we get the new value. We reassign this to the new value. What about the old value? Yeah, the old value gets removed or released. It gets released. Alright, we don't have the RC here, so we don't actually have an address here that we can use. Okay, let's remove the OX. Hey, Scanvar, are you aware that your game BizDex doesn't compile? No, I wasn't aware actually. Want to check your previous program? Okay. Are you? Which Zig version are you using? Cause I haven't tried it on either 0.15 or Master. Do I have it here? Yes. Wait, it should say here like which version it should be. Okay, maybe I just updated it to 0.14. No? What the hell? I'm pretty sure I updated it. Okay, wait a minute. Oops. Yeah, this doesn't have the new version. I'm pretty sure I'd updated it. March. I don't know. Maybe I didn't. Yeah, no problem. Okay. Oh, I see. Okay. One second. Let's see. Okay, I think if we do no, wait. Yeah, if we do build now. No. Fetch. Git. I think it's like this is the new place. What do you mean it's up to date? This one. Yeah, so let's just remove this. No. What the hell? Oh, it's in the cache. What's going on? Oh wait. There we go. I was like, went way too fast. No? Okay, well that's good, I guess. There's no weird caching issues going on. Where is this coming from? Oh, maybe it's one of the other dependencies. Okay, well, I'll do like one by one. So entity. Wait. This one. And CGE. This might mess things up, but we'll see. Okay, there we go. And now we have issues here, so you need to be like a root module. I think it's like this now. We just move it into there. It would be magical if it just worked now, but I don't think so. Fake camera. Target. I'm just gonna do this. I have no idea what this is. A fake camera. What the hell is this? Oh yeah. You want the actual includes now. which is what? Core AI rigid. Okay. Wait. Yeah. Okay. This is beginning to be a bit more than we bargained for. Yeah. Okay. You know what? I'll continue this another time. I want to update it to the latest. I thought I already had done it, but apparently not. I did update it to 0.14, but I apparently did not do it for 0.15. So I will do that sometime. All right. Thank you for updating me on that. I did have it in my back of my mind somewhere, but yeah. All right, let's try and fix this one. Okay, so this is called a non-allocated, released already. This one is coming from. Okay, this one is deinitialized. There, we should have like initialize as well, I guess. Which version? Okay. Okay, so the double or this failing one is this one. It's initialized after hello. Maybe I could, maybe you. Yeah, I mean, it is a string. We can see it's a string. I was thinking like maybe we can label it. Okay, so it's initialized, and then apparently release is called again. Maybe that's the scope. That gets deinitialized. Could be the scope. So, but we evaluate an expression which is just a string at this expression is just a string here. So that doesn't exist in a scope or anything. And then S gets reassigned. The value gets reassigned. So we deinitialize ourselves. Which makes sense. We deinitialize, but then we need then the same reference gets deinitialized again. That's where things go wrong. This part is just it's just generated here and then returned. And then we do reassign. And we do a move, so the new value needs to be kept around. Okay. Like, I don't understand. Hang on. This binding ref is perhaps creating a copy or not? I mean, or, well, because, yeah, okay, so the original is still in the scope. We only get a binding ref. The binding ref does have a pointer to the value, but yeah, this gets the original, this gets the actual pointer here. Okay. Yeah, it gets... Why does it get deinitialized again? Where is that happening? No, it's this one, yeah. The binding value deinitialized. Okay. Okay, now I remember here, yes, we have a binding value. That's just a way to keep the same structure here. So we have the name and the value. Now the value has a string in it. Okay, yeah, then this is also a ref. Oh, I see what's happening. It's my very clever automatic deinitializing call. So when we deinitialize this RC, this ref, since binding value has a deinitialize on it, it will automatically call this, which will also call this again here, but we don't need to do that in this case. Maybe that was a wrong move. I just thought it was clever that, okay, well, the RC could take care of both itself and the life cycle of its inner value as well. Yeah. How do we fix this now? I mean, we could rename this. That would fix the issue. I guess we could also not call this. Where is this called from? Actually, okay, deinitialize on binding will deinitialize. Oh, but that's a binding value. We could just call deinitialize on the binding value. Itself instead. Okay, now, yeah, so what's gonna happen here is this gonna get released. If this is the last reference, that calls the initialize here, and we in turn call the initialize on the inner type. Which is this one? Which should be good. I mean, that's fine. Yeah, this is the thing. Okay, let's do this. Let's do like oh my god. Okay, let's do like here. So log debug, reassign, and I'm gonna say binding ref. Oh, this could really, the binding ref, this could really just be the binding value, to be honest, right? We could just return the binding value here, to be honest. Because then we could also know which RC we're talking about. So let's actually change this to binding value. No, we can't. Okay, I'm just gonna do this stupid thing here. I'm just gonna say this is RC binding value ref. Yeah, the constant's probably good to have that as well, but let's just do this and let's make it null optional. So when we create the ref and when we look at it, we could determine what to do there. So here's like if it's mutable, or yeah, RC is gonna be if this is mutable, then we're gonna take that out, copy that over, otherwise it's null. And then we go back here, and now we can say, okay, RC, actually yeah, it is mutable, so it has to exist, yeah. And then we get the RC there. So that is the pointer to the RC. Oops. And now we can see where the reassign is happening. It's happening here. So the leak or the release of non-allocated is called or deinitialized here. Reassign is happening here, but it's reassigned. The RC is actually this one, binding value. Okay, so we have to look at the inner value. And I'm just gonna do some assumptions here. So we have a pointer. Actually, we could do get pointer, sure. and then we have the value, and it's going to be a string which also has an RC that we can print as well. So now we see here, first we have a binding value that gets initialized over here. So this is when the scope is, I think this is when the scope gets initialized. That's happening over here. And then we have this one which gets deinitialized directly here. So this doesn't really make sense. Yeah, I think it's the RC to the binding value that we want to release, maybe in that case. Or do it? No, maybe not. It's like, no, wait, which one is it? It's this one. Which is this one? So maybe this one is not a problem, actually. It's this one that's a problem. And that happens before reassign. Or it's initialized before reassign, okay. Well, I guess it's this one, I guess. If we do this, it should happen before. Yeah. Yeah, so it is the new value. Okay, so the old value is properly deinitialized. The new value gets deinitialized right away as well. Let's see if it's happening here. Reassign completed. No, it's happening afterwards. Okay. So like we return this value, which has the thing, and it's used here. Are we supposed to clone it then? Maybe we're supposed to clone it here when we return. Yeah, because this is like reassigned, so this is actually changing the scope. The value we return should be cloned. There we go. Yeah, because that's a convention here. It's like every time you return a value from these functions, you're supposed to clone it so that then they can like clean it up. If you're copying a value from the stack or from the scope, I mean, they get cloned. Okay, well, that makes sense. It's just sometimes hard to remember all the rules and stuff. Okay, now we can remove all these logs here. I do like these logs, but let's just have like logging, log enabled, false. Let's do like this and standard log debug. this would be like if log enabled, we will do this. All right. This one we could probably remove. Yeah. Okay. There we go. Cool. Reassignment works with no leaks. Okay, and then you can like, you know, set s equals something else, and then we set s, and then we echo s, and that should also work now, hopefully. There we go. Hey, it works. Okay. All right. So now string reassignments work, and strings got like what is it called when it goes back? Regression errors here. Now we can actually do this, and everything should work. No. Oh, duplicate binding. Oh, I see. Okay. There we go. Awesome. Okay. Did we tick off anything here now? No. Reassignment, yeah, that works now. Also, to note here is what I did was I refactored like basically all these strings in the scopes are now reference counted, so that it's not like I mean you can work without it, but it's just so much easier now that we don't like with all the like reassignments and everything happening. Now you can kind of, and it's also way easier to like pass strings around as well. Like if you create a new reference, that's only when you need another copy somewhere that you don't have control of, basically. And well, basically I can show you here. So evaluator, we have like render command port, for example. Now here I made a bunch of convenience functions as well, but basically here now we have like a dupe on an RC reference counter reference here that will automatically create a new reference counter for and duplicating this string that we get in here, this value string. Well, it has to be a string basically, or a slice of something. So that will create a new reference counting, but it basically is when you take something from the world of outside of reference counting and put it inside the world of reference counting, that you can use this one. And then we have like render string literals. No wait, let's do materialize string, because this was super easy as well. like let's say you have a value. Now this value presumably comes from the scope or somewhere else. We can't really use the value directly, so we have to create a copy. Now if you have a string that's already, this is already a reference, so that you can just make a new reference here. And it works well, because the original needs to be, we don't own like the lifetime of this, so we don't like release that or anything. We just create a new reference that we need, that we want to use. But you still have to manage everything. You still have to like manually manage the things, but it becomes a lot easier, I feel, when you can do this. Also, another like upside to this is memory usage. So you don't have to like clone a bunch of strings everywhere. You can keep huge strings in a reference counter, and it will not, you don't have to copy it every time you want to use it. Now you can have it the same copy in a reference counter, and it gets deinitialized whenever there's no references left, which is really cool. So yeah, basically like a very simple garbage collection, but you kind of have to like manually, you have to tell the reference counter when you don't need the resource anymore. So I mean, yeah, it works. And I also made this print convenience function as well, which is kind of the same thing as dupe, except you can print your own format here. This part we only have like an int and a float here, but yeah, it works. Also, we don't need to have the here. There we go. Yeah, so that's cool. And I thought about having strings also, like, you know, in there's a data type called rope, where it becomes very easy to like append strings together. And another benefit of that also is that if you have a string and you append it to another string, you would have two like string references, string reference counted, you know, things of those two strings. So when you append a string to another string, you don't actually get a new copy, you use the same copy because it's reference counted, and then it gets automatically garbage collected when all of the references are released. But the rope is basically like a linked list, you could say, of strings. And to get the whole string, you just iterate through all the items in the linked list to get the whole string. So that would be kind of cool, because then you get like mutable strings that are very easy to work with, and they are also like memory efficient, sort of. And yeah, that's pretty cool, but that's maybe for later. Like right now, we're just gonna have to make a new reference. Like whenever we want to change a string, we basically just release the old string, make the new string into a new reference counted. So basically release the old string and then make an entirely new string. Yeah. Even if you just append the old string to another string, we just make a whole new string with the entire thing in it. Well, that's fine for now. Except there really is no like string append. Like you can't append a string. Actually, maybe we can do that now. Or should I do? Maybe I want to try like maybe Advent of Code, the next one. I've done the one already. Okay, let's just do. No, wait. I can't make no line up here. I'm just gonna see how easy this would be. We have add, and we have add for numbers here. But what if we have a string? So if we have a string and another string, let's enable this, then we need to generate a new value that is a string. So basically this will be a string, and then this will be like print, and the format is going to be two strings that gets added together. So left string dot get try and try the right string get. Try. So this creates a whole new string, reference counted, and we just return that. Okay. What's that? What else is in the way of concatenating strings? Let's do s equals to s plus something else now. Okay. Expected string start got plus. What? Okay, so let's see what we have here. Oh, I see. We have like a pipeline parsing here. The first one. So this is. Oh, I see. I think we do try to do an arithmetic or a binary parsing here, but it fails because it didn't expect a string here, I think. So let's go to the parser and parse binary, or maybe binary. Wait, parse maybe. Oh, didn't I rename this? No, I didn't. Maybe binary. And then we have like parse arithmetic somewhere. Arithmetic. There we go. All right. Now what's happening here is, well, we could look at what's happening because we can say document store, and here we can say document parser log enabled is true, and then we'll do this, and we'll do print st. Okay, let's see. Yeah, it repeats, it goes back a couple of times. So here we have s hello, echo s equals no, echo this. So here's the function, and here we parse a statement and identify expression, parse identify expression, parse pipeline. Okay, so it goes directly into pipeline mode here, which we don't really need. We want to be able, we want to try a arithmetic first, I'm pretty sure. I thought we did that already, but yeah, maybe not. When we go in here, we have an identifier. If the next is a token or a sign, we go into parse expression again. which means now we should have s plus something. So we go in identifier again, and then we're looking for dot assign right. I thought we had, oh, I disabled it. Why? Now this fails here. One sec. Okay, so think maybe we're getting in here because we don't get any of the, like, these are the possible binary operators, and then if we don't get that, we go in here and we check if we have a terminator where, you know, string start is not a terminator. So we should get here to restore the snapshot and then return null. The snapshot is taken at the start of this. So it's taken at this point. So then we should stand here at, then it tries to parse the pipeline. It should parse the pipeline from here, not from this. So for some reason, this does not get reset back. Maybe, okay. Let's see. So the identifier expression peaks twice, or 2 ahead. We get identifier next token, and if we have an if we have a terminator, we parse the pipeline. We should probably just move this up here. And I don't think that would change anything. No. Wait, but now it does. It did change something. Now this says echo here. Okay, that does not make sense to me. Is something wrong with the peak thing? I mean, yeah, it could be that the current token gets, I don't think that's like a sign that it's a bug somewhere. Well, it is a bug. It's a bug in how this is displayed, maybe. But hello, Penguin. What are you up to? But this is reading an identifier, and then it should try, but that should happen here, I think. Wait, we're picking, so we're getting an identifier. Next one is the string, right? So that we should that should be restored here. Restoring snapshot to do we have an index here? I don't think so. I mean, we have this. We could also look at the token name, I guess. Do we have a format here? Is there a format on the token? No. Restoring snapshot to identifier 31. Yeah, okay, so now the current one is identifier. Good. And then it tries to parse the pipeline and something fails because it got a string start for some reason. No, we'll do this first. And then we restored it. Restored. Restored snapshot to here. Okay, it feels like this is like a mismatch now. So current is identifier. Does that mean that next will not be identifier? So maybe this is wrong. Oh yeah, this is wrong. Okay, why is this the current? So the snapshot is wrong. Does this sig test still work? Yes. So we have this test where we're testing like the restore and everything, but restore to the snapshot. So at this point it seems like the current is actually the identifier, which does not make sense because this would like fail spectacularly. I think this would fail. No, this would be a string start or something. But it says identifier here, so I'm confused. No, okay. Yeah, I am very confused. This will be identifier, then it falls through over here and we consume the next token. And then we got an operator mode, we find a string start. So then we restore the snapshot and return. Okay, let's look at this snapshot here. Actually, let's do this. Took snapshot at okay, took snapshot at identifier makes sense. No, it doesn't, because this is 31 and this is 27. That does not make sense at all. What the hell? Is current the one that we... Okay, hang on. Current is updated when we do next. Yes, that makes sense. The thing we return when we do next should be that. Guarded next. Ah, this is not okay. That shouldn't happen. Yeah, because that guarded next is also called when we peak. Okay, this should be way more correct. But what happened now? Current like disappeared here. String end. So we got a current token. I think what I want is maybe even hang on, when is this set to null? Never. Okay. Actually, okay, no. It should be set here as well. We should get, right, we should get the token here and set it to that and then return it. There we go. Okay, now it's advancing here. Yeah, it took string start, but the string start seems to be a little bit off. The peak token position seems to be a little bit off. Okay, and the start is maybe, I guess the start is, we're kind of covering the whole peaked area. All right, so we're kind of showing like the orange is the current token that we're looking at, and then the purple is the peaked, where we've peaked here. String text hello makes sense. String end, yeah, that makes sense. But here we stop doing it because presumably I think it's because we're now on the next line. Also, we still get this, which doesn't make sense. Because it doesn't make sense that the current token would be further along than the peaked token. Do we not clear up the peak tokens? We do. So it's like when we go next, if we have any peak tokens in the buffer, we take away the first one and return that. If we're peaking, we're looking also, well, if we don't have peaked items, we need to create one or add one, and then we can return that. And for the slice, we just do the same, but we need to calculate how long, how many items we need to peak or grab, depending on how many you want and how many we already have. And then we return how many ever you want to see. Consume if is just using the same interface, so this should be good. Now guarded next is like the actual function, the function actually consumes the next thing. Hello Zaflins, how's it going? We are dipping the parsing nest here. Now this makes sense here. 32 is after 31. But this does not make sense. This is supposed to be the current token, and then here's the next one. So there's some discrepancies going on here. That's why I'm trying to figure it out here. Yeah, at this point we should have taken care of all the peaked things and stuff. Restore takes care of the peaked tokens. Current is gonna be set here as well. Actually, you know what? We took a snapshot here. So that was before restore. We took a snapshot here. This also is like afterwards. This assign is after the string start. That doesn't make sense. Wait, is this 20 something else than this 19? Hang on. Okay, I might have done something stupid here. As usual. Let's see. Yeah, this is the index of the Lexer. That is not great. This should be like if snapshot current span start offset, else I guess no. All right. Okay, now it makes sense. 17, 19. Yeah. You can even see it makes sense. 17, and this is 2 after. Okay, now 26, 27, 26. Okay, now it makes sense. Okay. Cool. Let's see if we get these lines written here. So we have the log thing here. So we're skipping the lines if the token is spanning over several lines, or if somehow the end column is less than the start column, which doesn't make any sense. And it stopped doing stuff when we did what? Was it like -1 here? No. It should not be 1. Okay, why is it bailing out now? Working on statement parsing. Yeah, I'm right now working on like the basically debugging the, like adding more debugging stuff for the parser basically. I ran into an issue where, yeah, the parser tried to read an expression and failed, and it started to become a little bit more complicated, so I just wanted to touch up on the debugging part. Let's do lexeme here so we can see, or yeah, let's do lexeme. No, this is print. Three to 4. So all these are, line is 3 and start is 3 and end is 4. And they all seem to be like new lines. String end, hello. Then we get a new line. Okay. Let's do like if lexeme is length is 1 and it's a new line, we will return, oh hang on, we have to return as well. We will return like log new line, so this will be like self log, no, log new line token. Did you already have expressions handled, or are you working towards it? Well, I have some expressions. There's probably still more to come. I can show you in a little bit here. Let's see. Well, I can show you right now actually. So basically this is kind of where we're at right now. We also have import, rudimentary, but here's some tests for you know, equality comparisons, like Boolean stuff as well. So this all works here, and yeah, arithmetics comparisons. Here's a test for like binary operation precedence, which works now, so that's great. We have like functions, we have mutable variables that you can also string interpolation here, reassign. I'm currently working on this, the string concatenation. Did you go with Pratt for your expressions? I don't know is the short answer. Maybe, perhaps. I mean, when I look at the kind of theory and hearing it, I mean, it's kind of like how they explained it is like recursive plus loops or something like that. I mean, I am kind of doing sort of that. So basically how I do binary is I read every component here into a list as long as we have a valid like extension of the binary expression until we reach the terminator here, which is the end line for this in this case. So everything is being put into a list. So we have like a number, an operator, number operator, number operator. So every number, so this would be either number 1, either number 2, 3, 4, 5, 6, and so on. And then I did like I gathered all the operators and sorted them by precedence. Wait, did I do that or did I do something else? I don't remember now. I went through a number of different ideas in my head. But yeah. Basically, we go through the lowest precedence first. So in this case, it's the and then the left part is now a sub list that we then call the algorithm recursively on, and the right part as well. And then if you have multiple, we actually do like an iterator. So basically every list of things becomes an element in the iterator basically. And then there's a little bit of also glue when you have more than, you know, one binary operation. You have to, like in the same precedence, you have to sort of store this as one expression and use it as the next part. So we evaluate from left to right in that case if you have like multiple precedence or multiple operators in the same level, so to speak, in the same precedence. You just implemented in C if it's really too easy. Okay. Yeah, I don't know. I didn't read. I saw the article, but I didn't read because I had my own idea and I wanted to try it out. But I didn't read the article to see exactly how they did it. But yeah, it's available right now on my GitHub. I can if that was the correct link, if I spelled it correctly. Yeah, it should be good. And keep in mind, a lot of things are like, this is based on like an AI generation foundation, so a lot of the docs are like AI generated. So keep that in mind. I haven't like personally gone through everything to kind of fix it, but so yeah. So a lot of things is like irrelevant to what's actually implemented right now. And there's even like big parts of the code that is not used right now because it's like the old AI stuff. Your GPT and generate API document readings all the time. Yeah, I mean it's really useful. I'm gonna touch it up a little bit, but yeah. All right. Let's see. We want to log a new line token. So we basically we want to do this. Right, no prefix, I guess. And this one as well. Stand out interface. I guess we could make like a writer, so we keep the same. Get recursive design so I can do function block statement parsing later tonight. Alright, cool. It's so nice to go and actually do a little bit more advanced so that you can get like more depth in your knowledge. Instead of doing like a tutorial over and over and over. Member function. Oh yeah, you need a writer. And so basically want to do the same thing. Hang on. And then we do this one, and this one. Except we're not gonna have post. We're not gonna have this. We are just gonna, you know, write I guess we could do this for end of line. Okay. Okay, it works. That's good. However, it's kind of a weird situation. Why is this always new line at this point? Yeah, that's a bug. I prefer it in written explainers on a topic when I try to implement parameterized fashion. I myself breaking the thing that was, I was developing more understanding, was trying to fix it. Right. Yeah, for me it's kind of like, I don't know, sometimes I feel like watching a video, sometimes I feel like reading, because sometimes that's way faster to find what you're looking for. Just skimming through something. A video is just so slow, and it just feels so sluggish. I guess videos are good for when you maybe want to learn something new, or you're just putting it on in the background or something while doing something else. Blindly copying pasting tutorials isn't a good idea. Yeah, I mean, I guess what I mean also is like going past sort of the shallow implementation and try to do something more advanced, like to further the knowledge. Hello Blue, did you say thank you to the bus driver today? I haven't seen a bus driver in, I don't know, I haven't met a bus driver since I don't know, a long time ago. Customize it. Read about AST and decided to flatten it in my own implementation. Huh. What do you mean by flatten it? Like, do you not have a tree structure? Do you have a list structure? A list structured AST? What's your favorite Swedish chocolate? I mean, I like Marabou. Yeah, I guess that's it. It's like a milk, sweet chocolate. Very basic, but it's so smooth. Actually, you know what? I'm not sure if this is Swedish, but I do like the nougat chocolates. We have one called Guld Nougat, which is super tasty. But it melts very easily, so you have to be careful. It's not a tree, it's a linear array of what are called IR tokens, trying to get a generic I string that can be covered with AST if we want later. Oh, that's interesting. I mean, okay, I guess that makes sense in you know, if you're gonna make a assembly program, because that's how the program is. It's just an array of operations. Those tokens have an operation op token and then an array of tokens to represent operands. Right. Yeah. So it's an AST node already, just an array of them, not a tree. Okay. I mean, how do you do like control structures? Or do you have like, is it like assembly that you're jumping around, or how are you doing it? Hierarchy is encoded because of how the parser works. Huh. Okay. Interesting. I mean, I don't know. To me, I mean, that sounds really cool. I don't know. I just feel like the tree, it makes a lot of sense, but I mean, sometimes it's hard to, if the tree is super deep and it's kind of hard to parse what's going on sometimes, but when writing the code, it makes a lot of sense. Super fun, by the way, this whole adventure was inspired by you. What? With this language? That's awesome. I'm glad I could be of help. Or inspiration. An inspiration source. That's awesome. Yeah. So, okay, so your language, wait. Which one? There was someone who posted a language example. Of their language, but they didn't want to say what it was named. Well, I guess maybe it didn't have a name. I really want a scripting line for my engine and parser for my asset pipeline. Ah, I see. Yeah. I have a parser for my assets. The animations. These are generated from JSON files here. Blue, yeah, go ahead, shoot. Oops. So I have like animation. This is like an animation container, and it has 2 animations. So it's all like available in the game code. I've also like embedded the actual like asset ID in here, but I don't know. Yeah. And then you can like load the animation without because you have the ID is kind of mapped to a file name, so you don't even have to. You just load it. We have everything ready, and then you can like get the data here. So that was kind of cool. Like it wasn't too hard to do this. What's your favorite disease? Mine is what? Favorite disease? I mean, what do you mean? Like to get? Or I don't know, man. That's a weird question. We're going for something way more compact unless you also bake into binary, but essentially the same thing. Right, okay, cool. I mean, it's fine, Blue. I don't know. I don't have a good answer. Wait, where the hell am I going? Yeah. I mean, the disease I'm getting, like old, or I don't know if you can call it a disease. It's more like an well, I don't know. A disease seems so. It feels like a very loaded word, like a very heavy word. But basically, you know, the common cold. I used to never get common cold until I got a child, and then now I get like common colds all the time. Will people judge me in the office if I say Jason in a French accent? Je sens. I've heard that somewhere. Test it. Test it and report back of what happened. Jason. Okay, so what is going on? What is happening? It seems like it's not advancing after the new line. So let's go back to like parse statement, I guess. We've been stuck here for a while. Whoa, what's happening here? Wait, are we even building it right now? Yes. Okay, some weird syntax issues. Alright. Poor statement. Skip new lines. So why are you not skipped? Hey Blue. Wait, I thought you were wait, were you I thought you were like a developer, or you weren't a developer, you were like learning or something. Should have asked what's the scariest disease. Oh, I don't know what smallpox does. I guess the scariest, like you have things like Huntington seems pretty scary. It's like after, I think like you live until you're something like 40 or so. I don't know. I'm not an expert, but basically you don't know if you have it, and then it's like genetic as well. So basically you have like a high risk of passing it down to your children. So if you know that you have it, you shouldn't, I mean, you're basically giving it to your children as well. So, and what it does is basically when you turn 40, you just die, or something like that. So you know, you get like a timer like that. and you start to like deteriorate or something like that. Hunting sauce. And that sounds pretty, because it's like you don't know if you have it. So if you know that one of your parents or grandparents had it, then you might have it too, but you won't know until it's like too late. And there's no cure, I don't think, either. Hey, Burrow Checker. Breaking Bad. I haven't seen that. Token, peak token. What is happening here? Catch, return. Okay, so we're peaking. If it's a new line, we consume it. And we're done. Why does this suddenly stop work? Diabetes, yeah. Oh shit. What the fuck is going on? Okay. Parse statement. Skip lines. Wait. Where's the... thing? Skip new lines. Oh, but that happens after. And then we parse. Where do we get actually? I mean, we are advancing. It's just that this doesn't advance anymore. The current token. Maybe that's what's wrong. Like, it's just a current token that doesn't get advanced. A scary disease would be to which wipes out humanity. I mean, yeah. That would be pretty scary. That would be scary. Hopefully we don't have to think about it. Hang on. Wait, what was I was thinking about? Yeah, the current token is the thing that's not correct. We're peaking. That sets to that. That's fine. Whatever we return here should be the current token. When we peak, the current token should stay the same. We shouldn't change the current token based on the on peaking there. What is going on? Parse script self-stream lexer log enable true. Okay. That looks great. Here it's actually like advancing here. It's because we haven't. Okay, it's okay. Let's do this. Let's do one for current and one for peak. I think that's the issue here. Actually, let's remove this. Borosek, yeah. Really, yeah. I guess. I mean, okay. The thing is, like, how it works right now is like, it's sort of each line is kind of like its own statement, you could say. So the new line is like a terminator. You don't really need statements. You know, everything could be an expression. And you just have a list of expressions, and those are like the topmost, like the expressions at the topmost level. So you know, there's really no meaningful distinction between statements and expressions in this language here. And it's probably better if everything is an expression, because then you don't have to worry about differentiating the two in the type system or anything like that. I do have a statement expression as well. So basically, this is kind of like, this is a statement expression, which is like a pipeline. Now you can have it in, you know, you can, you can assign it to this. You can also do like, have it in the parentheses and do something else with it, or have it like this. So it is an expression, and if you have a statement that only has one expression, then it's a statement expression basically. Isn't this or this CFG violation? Okay, CFG, let's see if I remember. Context free something something violation, as it requires context or whenever you're in template or text. Context free grammar. Yeah, I mean, the expression in an interpolation here has access to the scope outside. So like, it has the same kind of access as, it's the same kind of scope as the yeah, it's not like a bash I don't know, expression inside here. It's more like, it's just an interpolation, a string interpolation. Yeah, we don't have other types of interpolation. Like, there's not gonna be this. This is not allowed. This is just gonna be $s here. This is the only type of interpolation there's gonna be. And then in here you can also have any kind of expression, like you can have echo, you know. This is gonna be the same thing basically here. So it serves it serves you know, the purpose of both just interpolating a variable in there, but also any kind of expression you want as well. Wait, unless your language specifically meant not to be concept-free grammar, advise changing it to $. See if you make it messy to lex parse. I see. Well, I mean, I already did like the lexing and parsings for the interpolation, so it's already implemented, and it's even the highlighting here is kind of it's not exactly implemented. You can see the highlighting inside is kind of have the same. This should really be, you know, an expression, but it didn't really quite manage to do it. But you can have multiple, well, you have to have a string, but you can have multiple things in here. You can have like echo and another thing, whatever. So this is already like implemented here, which took I think yeah, it was a bit tricky to get it to work, but basically how I do it is I parse it as a list almost. So the parser, or no, that actually the lexer has a context stack. So at this point, so here we have no context basically. We're at the root context. When you go to the first, if you're in no context and you're in a double quote, now we push a string context. So now we're in a string context. Now this is special because you can have like spaces here. Everything in here is read as a string text because we are in the string context. So this will become a string start token, and this becomes a string text token. And then if we encounter an interpolation start, we will now have an interpolation start token, and we also push an expression or an interpolation context onto the context stack. So now we know that, okay, now we're in expression mode again. So now we read the next thing as expressions again. So it's basically we're changing modes of the lexer depending on which context we're in. And so now we read this as a string again. So this is string start. So now we push another string context onto the stack and so on. This is a bit convoluted here, but basically let's say we ignore all this and we go back over here. So here we get here. Now we get to an end of a string here because we know that we're now in a string context. So if we encounter a double quote, now we have a string end token, and then we encounter interpolation end and so forth, and then we pop the stack whenever we encounter ends. And then at the end we pop the last item on the stack, and now we're out of the string. Now we're in the root again. This works like JS. Yes. Template head, middle tail, internal template part for expression text, and no substring literal. It violates CFG but works for CDG. So what kind of problems could arise from this? Yo, welcome back. Also context DG, like what is that? CDG? Because I don't see what the issue could be here. This requires you to manage lecture state and mode and adds complexity parts. I see. Yeah, and as I said, that's what I'm doing. Like I had to add a context stack that I need to push and basically changing the mode of the lecture. But it's really no problem. It's just a way to make it work. Context dependent grammar. I see. But what is the issue with that? Hello Metallics. Welcome. Well, I guess I would have to read up on that a little bit. I guess this is what I'm used to. I'm used to like this kind of style, so I don't know. And of course Sig doesn't have interpolation at all, unless you're counting like the print function. But okay, well anyway, let me go back. So we have some issues with the parser. I think I know what's going on here though. The lexer, okay, it's kind of the debug messages here. Okay, ignore all this here. The big debug messages here is showing which token is like the current token that we're on, and then it's advancing here, and the purple part is like which token have we peaked to. Okay, but if the peaked is like on the next line or doesn't exist, we don't see it. And I think that's what's happening here. I think here is like we haven't really consumed the new line, so it never goes past it. However, that doesn't really make sense because it should be consumed after this, so I still don't know what's going on. This says new line though, new line at 26. Yeah, okay, so it doesn't go past that. Well, this shows the current, so, and then the peak, and this we have peaked. Okay, anyway, what I wanted to do is I wanted to show the peak token as well, even if it's on a separate line. Where is that thing? Log, whoops, did I see? No, log that current token. Let's make another one called log peaked token source line. Now this is only get called if the current token is in a different place. So I'm gonna get the peaked token, and then we'll do this, and otherwise that, but we don't care about peaked here now. So there we go. Okay, now if we have peaked, we show it, otherwise we do this. But here is like if the line is different, I'm gonna say if, let's do it out here actually. If we have a peak token, and if the line is not equal to, let's do end line, or the end line is not equal to the end line, then it's on a different line. So then we will do try log peak token source line. Okay, yeah, that didn't work. Start line is not equal to token end line. Peaked end line is not equal to token end line. How are you doing, Metallics, by the way? I'll probably log off here pretty soon, but yeah, I need to sleep. I'm starting to slow down here. Why is this not working? It should say, well, okay, if it doesn't exist, it doesn't exist, of course. Well, okay, let's do, well, it should exist because we have it here. Yeah, it should exist. I'm just gonna do log debug here. Logging peaked. Let's just do like a JSON format. Peak. What? Okay, so it didn't have peak? This doesn't make any sort of sense at all to me right now. Why do we only have peaked up here? What the? Spent 4 hours fixing my compiler, added struct support and was working incorrectly for global variables. My games didn't work. Use snake X. Switch to snake point, that's what happened. Right, so you have structs in your language now? That's awesome. Switch to snake point, and then it worked? Or did it not work? Or wait, did the struct work or did the non-struct work? Anyway, that's really cool. You're building a game, you're making a language and you're building a game in it? That's cool. Yeah. What the hell, man? What the hell? Okay, here we go. New line. Identifier. Why is it not going forward? Oh, it's restoring. Okay. It broke when I switched the structs. Oh, I see, I see. Do you want to show like a snippet? Yeah, see, we're peeking as crazy here. But it doesn't do anything. Like at this point, we should have a peak token. So why isn't it showing up here? Oh, I see. Oh my god. It's because we're doing this. Or not. Wait. No, we should just try it, yeah. No. We'll do it here. Okay, and then this should be that. No, black, violet. There we go. Oh. No. God damn it. This one should be violet. There we go. So, okay. Let's, now I have a whole bunch of stuff here. This one, these logs I want to remove. There we go. Okay, now, so here's the current token, here's the peaked token at this point when we enter here. Peaked token, yes, that happened before. This I'm just gonna ignore. Maybe I should focus on this parse script, and we're skipping token because we don't have one. We shouldn't have a token actually at that point. Yeah, we should just return. Why is this even... I don't know. Okay. Yeah, we are parsing a binding, so we're consuming this now. And then the next one is an identifier, and then we need an assign. And then we have a string start. Yeah, and we're parsing that, and we have a string text hello, and we are taking that, and we have a string and now we're picking new line, so then we know that that's the terminator. I guess we do next new line, pick this identifier. Alright, and then we do maybe binding. Still looking at the thing, except it's not a binding, it's not a function, it is an expression. It is an identifier expression. Now here it should actually be consumed here, I think. Or maybe it's not. And here we do maybe binary, where we look at this identifier, we take a snapshot, which should be correct now. This snapshot should be correct. And then we should actually advance this token here. Yes, we do. Okay. Good. And then the next one is a string start, so it's not... Yeah, okay, so far so good. Then we restore the snapshot back to this thing here. So we're basically restarting this line. And parsing a pipeline, which makes sense, but then the peak token is string start, which does not make sense. It should be like the identifier. Maybe, right? Yeah, we're parsing the start token. What the hell is this? I don't remember this. Oh, I see. That's just to check where the whole pipeline started. Okay, and then we have last token. Yeah, okay, and next token. Sure. So we will parse a pipeline stage. Yeah. Okay, so at this point we haven't actually consumed the thing. Okay, now this one expects a token tag. Is that where things are going? The next token is a string start, and then we failed to parse because we expected an identifier and got a string start for some reason. So at this point, why do we get a string start? Because the current is here, so the next one should be the echo here. And we definitely have peaked tokens, so we remove the first item, set as at current, and return that. And then we also print it out. Next token is a string start. So this doesn't make sense. Wait, we took the snapshot here, which is a new line and an identifier, but then we restore the snapshot. This doesn't make sense. This list has somehow been modified. Okay, do we not make a copy of the list when we do a snapshot? Oh, okay. Let's add like pick thing. So basically here we're testing expected tags. This is what's gonna end up in the end. Expected peaked tags. New line identifier. Let's peak 3. So there's the snapshot. Let's do like peaked results. It's gonna be Lexer peaked or peak slice. Now this is like peaked before snapshots or something. So that's gonna be 3. So now we've advanced the peak to 3. And then we do a snapshot, and then we will, I'll just remove all this. And then we will peak some more. So we will peak slice 5, which will advance the peak further. And then we'll do peak after snapshot. Wait. Now we'll do like restore snapshot. And then now we expect peak. Okay, yeah. We expect. Wait, where is the testing? Oh. We expect equal slice, which is a token tag, and the expected is going to be expected peak tags, and the actual is going to be Lexer peak buffer items. There we go. And we run a test here. Okay, we don't actually need this value. And we don't need you. Unused local constant, expected tags. Okay. Wait, where is this? Equal slices. Expected const token tag for const. Oh, token. I mean, yeah, it would be more correct to try and do tokens there, I guess. Now, let's actually expect these. Sorry. God damn it. These are the tokens. Expected peaked tags. It's going to be an array of... No, these are the tags. Yes. And then we need to create like the actual tags. Actually, we can just clone this. Yeah, let's just do like peak tokens, buffer items length, testing, allocator, alloc, token tag. There we go. And then for Lexer peaked items actual alright, and then this would be here is the actual peak tags. Okay. Invalid enum value. We're going to calculate such expressions 10 plus 4 over 7 while generating AST. This is the only optimization feature my compiler supports. It's very easy to implement. Instead of having 10 plus 4 over 7 in AST, you can calculate it and have the only result between. I see. You're calculating it in the compiler. Actually, I did that. I don't remember if it was today or yesterday or something. We can now support binary expressions like this. This is fully parsed into an AST and will end up as like binary operations with only two, left hand side, right hand side operator. A bunch of those in a nested tree. And yeah, and then there's like operator precedence. So these ones, for example, they have like the lowest, almost. It's like the next to lowest precedence. So they will happen last. So basically this will be grouped like this. And then this and this is a group here. And then it will just be called like recursively in here. So now the next lowest precedence is this one. So this will be a group, and this will be a group, and then in this group, this one has this one has the lowest precedence. So this will be a group, and this will, and so on and so forth. So that took a while, but now it works. It works very well, actually, and it supports parentheses and stuff. So yeah, it works. I'm surprised at how well it works, actually. But now we're kind of back to basics here, because this is an error. Also, we get like invalid enum value for some reason. Instead found this. It's trying to write it, but it's like invalid. Expected new line identifier, and then it crashes. Did I forget to... Actually, this doesn't need to be a var. Why wasn't that caught? Tags. Is it because it's restored and then the things are broken now or something? Okay, let's look at this. It's broken anyhow. Something is broken. So we clone it. So we clone the target snapshot here. Actually, you know what? This is what's wrong. We return a snapshot, but we don't actually snapshot it. We just copy the whole array list. So after the fact, this array list that's in here will get modified. So at this point, we need to actually clone stuff. Okay. There we go. there it is. No. That. There we go. There we go. All right. Also, no, yeah. Okay, that works. Now the snapshot, if it's not restored, it actually has to be destroyed. So here we restore the snapshot. Okay, and what do we do then? We clone the snapshots. Yeah, okay. So we always clean up the snapshot. Yeah, we don't deinitialize the snapshot. That is gonna happen from outside. What? Okay. Yeah. There we go. Or there we don't go. There we go. God damn it. No, this is not errorable. What? Oh, this is not called. I see. Yeah. Whatever. Okay. What happens now? Does this work? Panic invalid free 839. we're cloning, and we're initializing our there, and then overriding the values and overriding clone. Okay. Wait, where was the error? 839. What did it say? Invalid free? Oh, no, that should be the same yeah, that should be the same allocator. Because we're using the testing allocator to create this. Snapshot, big slice, restore. That should not mess with the thing. We clone the thing, but the original still should be there. I mean, we initialize this one, which should be different because we reassign it to something else here, which is a cloned now. No, we're not doing this one. I don't understand. I don't see it. So here we create a new snapshot that should have a cloned list, and the only thing then that happens is we restore it and then we clone it again here from the snapshot and assign there. This happens before, we're not deferring or anything like that. Man, what is going on? Is it because of the arena again or what? Oh, maybe it is. Yeah, the allocator is an arena, so we don't even need to deinitialize this. Oh. Well, this one we need to deinitialize. Okay. Well, except we do get leaks. For some reason. Append. $700 peak slice. Man, yeah, I'm getting tired here. Because the thing is, this is initialized. We get the allocator. This is a text allocator, but as soon as it passes in here, this is now passed into an arena. Now we're using the arena for everything. And once the Lexer is initialized, it's just initializing the arena. Except for this one, which is used without the arena because of some issues with that. I'm not sure what was going on there, but and then when we whenever we do anything in the stream, it can access the allocator by saying self Lexer allocator, which in turn retrieves our arena allocator. So everything should be in the arena that we're doing here. But we still get leaks. We still get one leak. When we do peak slice 5 here, 839, okay. All tests passed as well, so the passes are good, I guess. Except we have a leak here. Oh man. Okay, I'll just ignore that. We can still go on here and run this.
and get double freeze. Yeah, because I just realized we're doing the same thing here. So the init snapshot, we don't actually need to do that. It's kind of weird. No, yeah, because self. Yeah, okay. This is not allocated with this allocator, so that's why we get this error. I'm just gonna remove this because we probably don't gain anything from deinitializing it anyway. So I will just not have this. Yep. There we go. Oh, what do we get now? Invalid enum value. Okay. Okay. So let's see, where's the snapshot here? So here's the snapshot identifier. Okay, now it looks good here. We're going back to identifier. And we parse the pipeline. Now we can't go past here, like when I think when we try to write for the parse pipeline stage. Oh, wait. I put some weird logs in here or something? No. Peaked token, I see. Invalid enum value. Well, that sounds pretty bad, to be honest. Like we are returning something that has an invalid. Yeah, this is just an enum. How can it be invalid? It's just. It has to be that the value is taken. I mean, either something to do with the arena. Again. Hang on. No, wait. That's just a slice, yeah. Where is this happening actually? It's before the breadcrumbs even prints. No, wait, this is parse pipeline. So we get past that. And then we peek over here to get the start token. Here's where things go crazy, I think. So we should be picking the identifier. And for some reason it doesn't work here. Because this does that, and then we log peak token, and then it fails here. it calls the format function, which has a tag. So wait, what the hell? Oh, wait, no, I see. We append. I was like, we should return in here, but we don't. But no, we append here and then return the item. So that means this returns like an invalid token. But then we should see next token. But we don't. What? No, because we already have peak token, yeah. Okay, so maybe something is wrong with the restore again. Okay, so we get the clone. That should be like super trivial to just clone it. Because that copies everything as well, right? Append slice, yeah. And then we just set this to the clone. That is equal to this. Yeah, and then but then we override clone. Or I mean this one. Oh, wait. The arena. We can't mess with the arena. Also context stack. Okay, we need snapshotting here as well. We do have snapshotting, but it doesn't work. Okay, when we restore, we should get the arena and then arena is arena. Okay, that's one thing. When we do a snapshot, we do the same thing here, except this is context stack now. Yeah, and here we get like context stack, no, s context stack clone, initialize. Not that it matters, we don't really need to do that actually, since we're using an arena, but whatever. Okay, now when we take a snapshot, we also want Lexer to be a snapshot as well. And Lexer restore. No, let's do Lexer restore. Let's do this. Lexer is self Lexer. Lexer, and then we do all this. Lexer restore S. Now let's do that before. Yeah, s.lexer, because that's the snapshot now version there. So we restore that. Then, actually I think we need to do try on both of these. Then you need to be Lexer. Okay, so when you take a snapshot, Lexer is also snapshotted. This one is cloned. We restore. We save the old Lexer. We restore that. We can also... No, we don't call deinitialize on the Lexer because that will deinitialize the whole arena. We just restore the Lexer. And then we set this back there. Yeah. We don't need to deinitialize really here, but whatever. Okay. Well, still get a leak, whatever. But, okay. Question mark? No. Index out of bounds. Okay, we got further. Let's see. Yeah, we got way further now. Now we got past this hurdle here. So this one tries to do an arithmetic, I think, or yeah, binary, I mean, but it fails. And then it restores the snapshot. We go back to the pipeline instead, and we do a pipeline stage. This is an identifier. Then we're picking a string start, makes sense, and it just consumed the text. And then when the interrupt start, we parse that. That all works. Okay, okay, okay. And then we get here consume terminator. Index out of bounds. Okay, so that's when logging out the peaking thing, I think. Parser 165. Okay, here. No, min. Start index 12 is larger than end. Okay. Okay, yeah. Fine. This, I guess. No, that looks bad. And we still get the same issue somewhere else. 167. The line is the same. Wait, do we do and or do we just do this actually? We probably do that. Line slice length. Okay, I think we got past it there. What the hell? Mem copy argument alias. Clone. Snapshot. It's failing at clone now. Parse binary expression. Okay, I think that's gonna be it for this time. I'm running out of time, unfortunately, here. But yeah, a lot of issues here. I need to... but it's good to get this done, because there was a lot of issues here. It's nice to get the more like debugging tools and... Alright, yeah, but that's gonna be it for this time. So thank you very much for joining me here, and have a nice period of time in the